Hello once again, class, and welcome to another mock lecture. We're continuing along with our 111Z prereq stuff. I called this one video 2 just because there wasn't a single topic for this one. We're kind of covering a lot of related topics. So let's start with domain and range. Here's a nonlinear function. It's got two endpoints. Notice one of them is closed, one of them is open. That is going to play a role when we're deciding how to do domain stuff. So quick refresher on what domain is. First of all, I'm just going to get this right out of the way. This is my notation for how to write the domain of a function. Much like function notation, the way that I would read this is domain of, and then I put the function's name in there, right? This is the domain of f. The domain, remember, is all of the places on the x-axis that are defined for the function, which means that there are corresponding y values for these x values. Like, for example, over here, I don't know what this number is. I'm just going to guess that it's like 12 or something like that. 12 is not in the domain because the function ends before that. If this is 12, this is 10. Again, I'm just guessing. We'll find out here in a little bit. But you would say 12 is not in the domain of this function. So we're trying to figure out what is in the domain. And so we're just going to look on the x-axis where there exists corresponding purple y values. The way that we're going to start this is with a set. So I've got the curly brackets here. We're going to stick x in here just to let everybody know that the domain is in terms of x. Really, what's happening there is we're saying x is all real numbers. But for the purpose of this video, we don't need to delve into how to write different universe of discourses. So I'll just leave it as x here. This is just reading the domain of f is the set of all x values. This vertical bar reads such that, and then we're going to put in our inequality. So let's go over how to do that. We're trying to bound x between two things. So you'll notice that x can't be less than -3. -3 is the lower, what we call the lower bound of this function insofar as its domain, because x, you can't plug anything that's less than -3 into it. So that's what I'm going to start off with. -3 is less than or equal to x, or similarly, you could say x is greater than or equal to -3. But in an inequality betweenness statement, I always like to have the alligator mouth pointing this way, because you're putting x between two things. So you're saying, right now it's bigger than -3, but it's not everything bigger than -3, because as we discussed already, like you can't put in whatever this is. I think it's 12. So we're going to have to cut it off with an upper bound as well. 10 is the upper bound here. But notice that in this case, x cannot be 10. There's an open endpoint right here, which signifies that while x can be anything up until 10, 9.999999999 forever, that's in the domain, but 10 is not. And that's the domain, right, of this function. Similar story with range. You'll notice I'm writing the same thing. I even have the same abbreviation, range of f. It's the set of all y values such that they're between some lower bound and upper bound. And the only difference you have to keep in mind here is that for range, now you're talking about the vertical available numbers. So instead of horizontal values, now we're looking at y-axis stuff. We're looking at vertical values. So your lower bound in this case, literally is the lowest point on the graph, and the upper bound is literally the uppermost point that's on the graph. Looks like here, the lowest point is 5, and the highest point appears to be 4. So notice that the endpoints don't really matter anymore for range. Like I could have a function that maybe does something like this, and we can have that one be open. Well, the lower bound's whatever this value is, and the upper bound's whatever this value is. Happens to be that the lower bound in this one is the endpoint still, but now we're talking about its y coordinate. But the upper bound has nothing to do with this endpoint. The upper bound's over here at seemingly 4. So I'm going to put, there's a visualization of the lower bound and upper bound, but I'm just going to put in the inequality here. -5. Less than or equal to y, so y is anything bigger than -5, but we need to stop it up here, so we say, but it can't be bigger than 4, so y is less than or equal to 4. Now you might be wondering, how do I know that that one's not just this? And the answer to that is, unless there's like an open circle here at the top of the graph, let's just always assume that y attains that specific value. So that's domain. Specifically, that's what's called set builder notation for domain. So there's two ways that you can write domain. One of them is like this, which is probably the way that you've seen before, at the very least, the inequality way. We're just putting an X with a bar and encasing it inside some curly brackets here. But there is another way that is way more shorthand, and it's called interval notation. And so I want to explain a little bit about how we can write intervals from set builder notation, or honestly, even intervals just from the graph itself. Again, what we have to do is keep in mind where things are closed and where things are open. But what I've drawn here actually is the correct version of the domain in interval notation. It's closed, so I used a square bracket at -3, and it's open at 10, so I used an open parentheses at 10, and then both of the set builder notation inequality symbols for y were less than or equal to, so I used square brackets for both of those things. But here's how it works, basically. I think about it as like a, a menu for a fighting game, like choose your character. Right now, A is open. A is an open dot, so it's getting the parentheses. It's getting the open parentheses on the left here, right? Talking about right here. B is a closed endpoint, so it gets a square bracket. Okay, but if I change this, if I fill in A, then what I'm doing is I'm selecting the bracket, and its consequence is that this gets filled in. Or I guess really it's the other way around. This gets filled in, and as a consequence of that, now we have to select the square bracket for A, because it's closed, which means X is allowed to be whatever this value is, A. If we open B, we have to select the parentheses for B, right? And then you could select parentheses for both of them. Okay, so that's kind of how that works. You're just kind of selecting different things here to determine what your interval should look like. Here's all of them. Because one thing that this model does not talk about is, well, what happens if there is no endpoint? What if there's arrows on both sides, which signify that the graph is doing this sort of shape kind of forever? Well, then you're talking about situations like these. So all of these ones have no upper bound or no lower bound, right? One of those things is true. And in this one, there is neither an upper bound nor a lower bound. The arrow signifies that it's going on forever. But the way that you deal with that is if the lower bound is the part with the arrow on it, then there's no lower bound. The set builder notation for that would just be X is less than or equal to B. It's anything less than this, right? So it's all of this stuff is what X could be. As an interval, you'd say -infinity, comma B with the bracket because it's closed. Right, if it's open, then it's an open parentheses. But this is all of them. I'll kind of, if you want, you can pause the video here to kind of take a look at this. These are all the different types of intervals that you would run into. So let's do some examples of this. So I've got three functions here, Q, P, and H. And I just want to find the domain and range of all these things using an interval. So we'll start with Q, and let's start with domain. So I want to find its left boundary and its right boundary. It's lower bound and upper bound, but on the x-axis. It looks like they're here just based on the endpoints. We've got -2 as the lower boundary and 4 as the upper boundary. I'm noticing both of those things are closed dots, so I'm going to use this as my domain. -1 to 4. I think I said -2 before, but I definitely meant -1. But there you go. That's the domain of Q. As far as the range goes, now again, looking for lowest point and highest point, for that one, it looks like -4, which it can be -4. Y attains the value -4 because there is no open dot at the apex of this curve here. And then 5 looks like it's the highest point for Y, so we'd have -4 and 5. Looks like I started P already for this one. Again, looking at domain, the thing I'm pointing out here in this slide is that there's a closed endpoint on the left and an open endpoint on the right. So we should have something like this when we write it. That's a square bracket and then an open parentheses. The lower boundary looks like it's -1. The upper boundary looks like it's at 2. Because again, domain's always about x-axis stuff, and like here's where we're starting and stopping. So then the way that we would write this is square bracket -1, comma 2. By the way, and I think this is a good point to point this out, you can't just write this, -1, 2, and then once we find what the range is, we write that down here. It's probably going to be square bracket, open bracket again. You can't just say this and then put a box around it and say, here's my answer. Because if I look at this, I don't know which one's the domain and which one's the range. So you have to put this in. You have to tell the reader, hey, I'm talking about domain with this interval, right? Or I'm talking about range with this interval. Because you'll notice what's different about intervals than set builder notation is that there is no x and y. Like if I write this in set builder notation, I guess I don't necessarily have to tell the reader that I'm talking about a domain because it could be inferred given that x is the thing that we're talking about. Now, having said that, you should say the domain of P is this if you're going to write in set builder notation. But the whole point I'm trying to make here is when you're using an interval, make sure that you're writing what the interval is next to it. Okay, with range for this one, it looks like the lower bound is -2. I would say that it attains the value -2, again, because there's no open dot down here. And then the highest value looks like it's 5, but it can't be 5 because there's an open dot. So square bracket -2, comma 5 is what we're going to go with. The last one has no lower bound, both for range and domain. We're doing domain first. If I was going to write the domain in set builder notation, I would just have x is less than or equal to 2, and that's it, right? Because there's no lower bound for this. But if we're going to use an interval, you'd have to use -infinity, comma 2 with the square bracket, because that endpoint is filled in. You never want to do square bracket -infinity, or even infinity with a square bracket. Because remember, the square bracket indicates x can be whatever that value is, but infinity and -infinity aren't values. They're concepts, right? It's not a number, so x can't be that thing. So you always, anytime infinity is involved, you always want to make sure that you're using an open parentheses there. But again, this one does have an upper bound. It looks like it is 0 because we're talking about y, right? Talking about the y-axis here. So it's all of this stuff. 0 is the upper bound and there is no lower bound. So we're going to go -infinity to 0. Now, the other thing that you can do is you can assess where graphs are increasing and decreasing by breaking up their domains. So like if I use P as an example, what I could say is that the function's decreasing on this part of the domain, on this part of the domain, and I think that's it, right? It's only decreasing here and here, but then it's increasing on its other intervals. And so we can actually write that stuff down. So here's an example, and I put the pause sign here because I want you to try and figure out what the domain and range are of this thing real quick before we talk about increasing and decreasing. All right, welcome back. This is what I got. The domain is all real numbers, right? -infinity to +infinity is all real numbers. And then the range does have an upper bound. Looks like 5 is the highest point you can reach. But then since both sides are decreasing forever and ever, on the left and on the right, we would say this thing has no lower bound. So -infinity to 5 inclusively for the 5 part. Okay, but let's talk about intervals on which j is increasing and intervals on which j is decreasing. What we need to do is we need to focus on the fact that we have to break this domain up into where it has positive slope and negative slope. And because we're breaking up only the domain, I'm only referring to x values when we do this thing. A lot of students want to attach, because we're talking about where it's increasing and decreasing, they want to attach some kind of verticality to the intervals that we're writing, but that's not the case. We're only breaking up the x-axis. If I could draw a straight line, we're only breaking this thing up into pieces where the slope is positive and pieces where the slope is negative. Where it's positive is where the function's increasing, and where the slope is negative is where it's decreasing. So you need to find the turning points, right? These are points at which the graph is changing its slope from negative to positive, like it is here, because the graph is going from negative slope to positive slope. And then also where the graph is changing its slope from positive to negative slope, like here. Positive slope to negative slope, positive slope to negative slope. These are called the turning points of the graph. And what I do is I break up my domain into these pieces. And I didn't actually do it on this video, but it might even help to write out what those intervals are. Like this one's -infinity to -2, right? This interval is -2 to 0. This interval is 0 to 3. This interval is 3 to infinity. Right? And what I'm talking about is this part here, 3 to infinity, right? -2 to 0 is that one, okay? But what that helps me do is it tells me, okay, here's where the graph is broken up to where it has positive and negative slope. So increasing is just going to be the ones that have positive slope. So this one and this one, because it has positive slope inside those intervals. But to be a little bit more clear, what I'm doing here is I'm looking for where the graph has positive slope, and I just highlighted that in this green color. So these are the intervals, negative infinity to negative 2, and also 0 to 3. When you want to say it's, increasing on this interval and also this other interval, you put a union sign between them. So x is in the set that is the unionization between negative infinity and negative 2, which is all this stuff over on this side, and also 0 to 3. Those are the intervals for which j is increasing because that's where j has positive slope. Decreasing are just the other two, but I'll highlight them again, right? It's where the graph has negative slope, right? Where does it have negative slope? It's in these intervals here, which are these ones. Negative 2 to 0, and then we're going to unionize that with 3 to infinity because we're saying it's this interval in addition to this other interval. Like these are all the x values that would give you negative slope. Okay, notice that I'm not putting a square bracket on any of these because let's say I put a square bracket here, why did I do that? Couldn't you make the argument that at that part it's also decreasing as well? But then you're saying j's both increasing and decreasing at a point, and that doesn't make any sense. No, at the turning points, what's actually happening is the slope is technically 0. And you're going to learn a lot more about that when you get into calculus later on. Okay, so a little bit longer of a video this time because I had to cover, 3 different topics, but they're all interrelated, and hopefully you guys learned something, If you guys have any questions, please leave a comment below or shoot me an email. Thanks a ton for watching, and I'll see you in the next one.